Do this last time?
Yes.
Did we get through it?
No, we did not finish it. We did the first one together, and then you told us to do the other two on our own, and that was our exit ticket so that we could leave. It was like 3 classes ago.
Okay.
So we've done it.
Everyone feels comfortable?
Yeah.
No. I'm seeing shaking heads. What do you want to see?
Do you have a charger?
Let's do it again.
What do you want to see? Oh, it again? All right, Carlo, get us started.
Okay. You got like.
Where do I gotta sit to use that?
You can plug it in there.
Formula,
Hey, bet.
that formula, A equals P-E-R-T.
Okay, so do you want to do A first? Quarterly? Oops.
Yeah.
Quarterly?
A is
Okay, so let me scroll back and show you what the actual formulas are.
It's a very normal
Should
shirt.
I write this down?
So your first question is, which formula do I use? So before you start calculating your account balance, you need to double check which formula you should be using. So if we're going to do problem A together, which one do I want? Carla, which one do I want?
You want the P 1 plus R over N to the
Yeah, so this is our formula for what?
Compounding, whatever that per year.
Right. So we call this the formula for discrete compoundings.
So I think you wrote some when we weren't in the classroom.
Hey, Maya's coming back in.
And then what is this formula for?
Mr. Shale, did you remember to record?
Piecemeal. So I recorded G block because even though I test and I try my best, it's technology. Something didn't record. So I think I have a complete record ish. But I've done some review, so I think in the whole set of lecture recordings, I think it's all in there.
Okay.
This second one, what is this formula?
For continuous.
Right, continuous compoundings. So if I'm gonna try to do problem A, which one do I want to choose?
Discrete compounders.
Right, discrete compoundings. That means that I know the number of compoundings per year. It could just be once a year, could be twice a year, could be quarterly, could be monthly, could be daily, or whatever it is. So if I'm gonna try to solve A, I'm going to first step is to do what?
Write your formula.
Write your formula. Always write your formula. A equals P times 1 plus R over N to the NT. What is P? What is R? What is N? What is T? P is what? 12,000.
0.3.
R is
0.3.
0.3 is how many percent?
0.03.
0.03 is 3%.
And then T is 5.
N is 4.
And
Well,
N,
where'd you get that?
Because it's quarterly.
quarterly means happens every 3 months, 4 times a year. So N is what?
4.
N is 4, T is 5. Get all these other ones, all these numbers from the problem, except quarterly comes from the problem as well. So let's plug all that stuff in. What do I write, Amelia? Sitting back and not making notes is not the way to learn how to do this stuff. You should be writing this down as we go. How do I start, Amelia?
For quarterly.
For quarterly.
I actually do have it written down somewhere.
Can you just tell me right now?
No.
That's because you're sitting back and not participating.
Well, it's
You're not
there,
following
so
along.
Okay.
Eric, how do I start?
No, I know how to do it.
Let's go.
A equals
Right, A equals, good.
12,000.
12,000, good, that's my P.
And then parentheses, 1 plus 0.03
That's my rate,
over 4,
that's my N.
and then to the power of 4 times 5.
That's my N times T, right. And at this point, yeah, Sam,
Can you explain the PRNT thing? What is what up there in the hood?
this
It says it.
one here,
No,
He's
no,
principal.
not what's the formula. What words are going with what line? So it makes sense.
for the problem that we're solving,
No, for my notes.
What do you mean? For the first one or
Where the arrows are, you see where the arrows are pointing
Yeah,
towards
yeah, yeah.
letters?
Right.
What words are in what line?
so this is explaining what all these symbols mean. So A is the amount, it's the account balance. So A starts with amount, amount and account balance both start with A, so you could think of that as either way for your for your A. Principal starts with a P. R is your rate of interest as a decimal, so that says rate of interest as a decimal. Sorry about my handwriting. N is number of times per year, number of compoundings per year, and T is number of years.
But the two random numbers sitting on top and on bottom, where do those go?
I said, for example, if we tell you that, for example, if it's a, yeah, go ahead, Sydney.
So like if you have 3.25%, your rate is 0.0325, because if you don't move it twice, then it becomes like a larger number than the original percent.
Got it.
So when it comes time to inserting my rate, if I put 3.25 or if I put 3 in there, it's 100 times too big because it's 3.25%, which is a smaller number.
Gotcha.
Okay, who has an answer for me? At this point, you can just put this in your calculator. Warren, do you have an answer for me?
Yes.
Sydney, do you have an answer?
I haven't put in my calculator, but I can.
Please. Charlotte, do you have an answer?
No, I did it.
Amelia, are you putting this in your calculator? Do I have to call everyone by name? Have your calculator out when you were taking notes so you can participate.
Wait, should I say the answer?
Go ahead.
1,241.048.
That's not what I got.
That's not what I got either.
I would say that's not even possible.
What? Too small.
So this is a savings account or this is an interest
Let me
bearing
retype it in a different way.
bearing account. So you're going to have at least 12,000.
Is that a 1 in the formula?
Yes.
One, yeah.
So it's raised to the 4.5.
No, 4 times 5. 20.
Well, that's what I was
Yeah,
confused.
But your 12,000 should not have shrunk by 90%.
Well,
So it should be 12,000 and something.
yeah, but I
Right.
raised it to 4.5, not 20.
Either way, if you're raising, this is a number that is larger than 1. So it's plus an interest rate divided by number of times per year. Interest rate we're always expecting to be positive. Number of times per year we're always expecting to be positive. So so you are multiplying your principal by a number that is larger than 1 multiple times. So we should expect that your answer is always going to be greater than your principal. It's not the stock market, right? It's not like sometimes you gain percentage, sometimes you lose percentage. This is an interest-bearing savings account. So you're expecting your money to grow. Kira.
Can I say what I got?
Okay.
Wait, can I say what I got?
We got the same answer, Carlo.
Okay.
Say it together, same time.
3,
No, I
Two.
can't do that.
1.
Tell me what to write.
13,000.
No.
Oh, dang.
Tell me what to write.
$.
Dollar sign.
Oh.
13,934.21.
Can I see your calculator? How'd you type this in?
Did you go to 3 decimal places and check for rounding?
Yeah, it's 20971. So you
Okay.
round up
Right.
because it's 1.
Let's see if we're continuing.
So on this kind of problem, did I have to say answer to 2 decimal places?
Okay. I got it.
Yes or no?
No.
I didn't. It's implied. So for dollar amounts, if it's a whole dollar amount, feel free to express it as a whole dollar. If it's not a whole dollar amount, express it to 2 decimal places and stop. We'll check for rounding, but only 2 decimal places. Did I have to say include the dollar sign? No, because you're including your units whenever possible. Sam, can you help us get started with B?
Probably not, but I
Oh.
can try.
No, that's not the right attitude. Can do attitude.
I said I could try. Damn.
You can do it.
So you're looking for monthly?
So I wanna name out. Yeah. Oh yeah. I wanna.
I can
No,
help.
no. I'm not gonna tell you. You tell me.
So if it's monthly, it's like 12 times a year. So I don't know where that goes, but that'll go somewhere. Oh, wait. Is it the number 1 formula? Is it the formula for number 1?
Yeah. So when you're given a question like this, your step number 1 is choose
Wait, how can you identify which unit formula to use?
your formula. When we get to part C, what is it gonna be?
Continuous compounds.
So which, yeah.
Wait, how do you know which formula to use?
So Sam, why did you say continuous compoundings?
Because for quarterly and monthly, it's giving you a set amount of compounds per year. Where for number 2, it's like it like keeps compounding, like it's always compounding instead of like certain moments.
For part C?
Yeah.
Yeah.
So it's like for quarterly and monthly, you would use the.
Oh, the first one's like only like a one-time thing, and the second one's like a constant.
No, so
Second
this
one's constant. That's correct. But the first one is like just any set number of times.
Oh, I see.
that's what we mean by discrete. So it's a number. So a discrete number of compoundings, as opposed to continuous compoundings. So step 1 is really choose your formula. Step 2 is
So for
assign all variables.
for B, you would choose the first formula for
Okay.
in compoundings per year.
Yep.
Which is A equals P multiplied by 1 plus R over N.
And I'm going to write my formula, right? You always write your formula, right?
Yes.
Okay, so now step 2 is we're going to assign all variables.
So now to A,
We're solving for A.
yeah, we all got A. P, would be, $12,000.
Mm-hmm.
R, the rate would be, 12. Or am I completely wrong?
Rate. So you invest $12,000 at an annual interest rate of 3%.
So
That's from the
3.
original problem, huh?
So 3%.
3 what?
0.03.
And how do I write that? Right. So I can't plug in just bare 3 all by itself. Cannot do that. It'll give me the wrong result. I need my interest rate as a percentage. I'm sorry, as a decimal, not a percentage.
And then N is 12. N is 12. Yeah.
And it's 12 because it's monthly. And is that everything? Yeah, I think we're ready to plug this in. Carlo, go.
So you want me to,
Plug it in.
okay, so A equals 12,000,
Yep.
per, 1, plus 0.03 over 12 to the, to the power of 20, or no, because it's n times, so it's to the power of 12 times 5, 60.
Yeah. If you wanna go ahead and write 60 in this you can. At this stage you can. But if you wanna write 12 times 5, that's also fine. So you're ready to plug it in. So Amelia, let me have your answer when you get it.
Wet. It's wet water. Interesting.
Oh my god.
Do you need to borrow a calculator?
Yeah.
Here you go.
You should be more organized. What? Should be more organized there.
You so organized, look at it.
So,
They call it organized there.
what? He said they call you organized Derek. No, it's not.
I got my calculator out for sure.
Good job, Carla.
Wait, my answer is not that different from the last one.
It's mine wasn't either.
No, mine doesn't even.
Okay.
Do you have an answer for me, Amelia?
Yeah.
Tell me what to write.
13.
No.
Dollar
You
sign, yo.
put dollars at the end.
You say dollars at the end. You put dollars at the beginning. You don't say $13,000.
Yes, you do.
You don't. I'm saying I was writing as I went. I was writing. You don't say. You don't write $13,000 sign.
Well, then you're not gonna like my homework.
So what do I? You don't put dollar sign at the end.
If you
don't do
say
that.
dollars at the end.
If you want to use euros, okay, put it at the end. There are other currencies where you put it at the end. Dollar signs, you don't do that. Cents, you do.
Sorry, how did
If you say 23 cents, that goes at the end.
Why do we say it at the end if we put it at the beginning?
So what's crazy is if you want to say 13.5, if you want to say Carlo and Warren,
You mean fridge?
if you want to say 13, if you want to say $13.5 billion, you write $13.5 billion.
If you went to the store and the cashier was like, "Okay, this costs $20," like you're a freak.
But if you saw it written as $20, you'd say that person doesn't know how to use American dollars.
Yeah.
All right. So what do I write?
Sorry. Dollar sign.
Yes.
13,939.4.
Wrong.
0.40. 1.
Wait, 401.
0.
40.
Just 0. No,
Just
no
40.
1.
40. Yeah.
Yeah. So we don't write dollar signs with like $9.4.
Stop it, Carla.
If it's $9, you can leave off the decimal. Carlo and Warren. If it's a whole dollar, you can leave off the cents. If you use cents at all, you use them both. And then check the third digit to see if you need to round. Sydney, can you help me with
yeah,
C?
You would use the same, or no, you would use the A equals P E, right? To
Pert?
or T, yeah, that pert.
Why am I using
Because
PERT?
it's continuously.
So continuous compounding, what's my formula?
A equals P E to the RT.
PE to the RT. Okay, what's my second step?
Then you have to fill in what you know. So P equals 12,000. R equals 0.03. A equals.
We're solving for A.
Yeah,
we don't really
so
have to say,
know
but-
A.
Right.
And then t equals 5 years because it's continuous, right?
Yeah.
Okay.
T is 5 years. So T is time in years on both formulas.
Okay.
So so what is N?
And is the wouldn't it just be 1 because it's
Trick
one?
question.
There's no.
There's no N.
Okay, brother.
All right. So let's go.
Okay, so
Okay. Go ahead.
A equals 12,000 e to the 0.03 times 5.
I want everybody to put this in your calculator. Everyone put this in your calculator. I'm not ready. I want everyone to put in your calculator. I'm going to come around and take a look.
Let me see my calculator.
No.
Let me see my calculator.
Do this separately.
Yeah, let me.
Where's your calculator?
I need it. It's dead.
So plug it in.
That thing is so like doesn't charge it.
Hey,
Mine is about to
this
die.
one's also dead.
Is it dead?
Yeah.
I got it.
See, it's already charging, Carlo.
Look,
Yeah,
Mr.
but it
Shade.
doesn't last. I could
Probably
do
because
it.
you
Mine-
plugged
my
it in for
So,
actually 4
so
seconds.
Charlotte, after I see yours,
Yes.
and you're going to clear your results, and Amelia, you're going to do that.
And then once I'm
Lauren,
done,
when you're done, you're going to clear your result, and you're going to let Carlo do it.
I'm gonna do it so good.
Made a mistake now.
I'm
Carlo.
gonna do it so good. Watch.
Hey, I did it.
P equals.
My brick, though old, I don't think I've ever changed the batteries in this thing.
Okay, come on.
Okay, so let's clear this and let's say.
Why used to call
Ah.
I'm still trying to
Did
write
you
the
do,
words
Kira?
for
I
A,
just wrote it
bro.
down. Last time I did it.
But you know how to do it.
Yeah. Oh, I can take my answer down.
Why did you use some red pen?
Oh, Charlotte.
Oh my god,
yeah.
you're insane.
Naughty,
Call back.
naughty, naughty.
power. Look here, Mr. Shadle. Look at that.
Good boy, girl.
I'm so good.
Waiting on you.
Let me write the notes.
Do the work.
Stop running so fast.
No,
Let me
no, just figure it out. I want to check that everyone can do this.
Well, I can't. So.
Mr. Shadle, did you
How
steal
nice
my
little
lid?
jeans are.
I didn't.
I just dropped my point.
You dropped your tip.
Yeah.
Oh no, that's so bad.
Hey, Carla, did you do the homework?
Good.
Where did it
What are we
go?
doing this one?
See?
Aren't they all the same answer?
Yeah, this one is.
But then why is there red on
Oh.
you did that.
Or like,
Do you
like
see
I'm
where it
gonna
is?
say zero
It's
off
50.
the last one.
Oh, it's right here.
No.
No, I don't even care
Eric,
that I
you're
don't have
so
something to cover it.
Chinese.
I just miss playing with it. 'cause
No.
I get
You're
it.
so Chinese.
Huh?
Eric is so Chinese.
I don't care for that comment.
What is so Chinese?
I'm so. What does that mean?
Carla, you're so American.
Carlo,
I'm
you're
so
on
American.
thin ice here.
So Chinese.
What an odd thing to say.
You like Hong Kong?
You're an interesting guy.
You can get help.
No, I think maybe I have it.
What did you say, Carl?
You like Hong Kong?
Hong Kong?
Hong Kong.
4.09.
Yeah.
4 point as your answer.
Where you from?
Yeah.
North or south?
No.
Well, we learned something. I can't do it. Yippee.
All right, so let's-
Notes now.
Yeah.
Let's
Yeah, everyone's
make
gonna use
sure
their chart.
that we know how to do this.
Are you closer?
And 1 cent.
Ocean.
Yeah.
Like I'm near the
Yeah. Most people in China live. on-
Carlo and Eric.
No, sorry.
Damn.
And number 1 eczema boss today.
is it blood?
Oh, because it's so dry that it starts bleeding.
Do you aquaphor?
Are you closer to
No, I
Beijing
hate
or
it.
Shanghai?
Maybe G?
Gross and disgusting.
Beijing.
If it's like I'm putting like Crisco.
Since your thingy is not currently loading, could I
Big
look
lord.
at the notes?
No, because I can't see when it's done loading.
It really doesn't like.
But aren't your notes on your iPad and not on your computer? Couldn't you just look at your computer?
I share my iPad screen to my computer so I can project it. And I can't do split screen because that messes up the recording. That's why I didn't have a good recording last time.
Is your iPad currently on?
Yeah, it is. All right, no, we're ready. We're ready. So Sam, get your calculator out and somebody tell me how to, Amelia, tell me how to solve this.
The one we just did?
Yes,
You do 12,000,
12,000.
then you do E.
Where's E?
You do out second, lim.
Second,
Lim.
ln.
Yeah.
That gives me E to the, it's ready for,
Where is that?
Power
here,
of-
it's here. It's the second above the natural log is E to the x.
That was not, okay.
E to the x. So, and then what, Amelia?
And then to the power of 0.03.
0.03. If
Wait,
your
is
calc,
it not alpha? Wait,
Second.
if your calculator gives you E and then caret, then you must use parentheses here. So for me, I'm up in the exponent area, so parentheses are option. I'll go ahead and put them in. It wasn't required, but I'll go ahead and use parentheses here. Yeah,
What is
where,
carrot?
how are you getting E?
Here,
It's
oh
like
my
a
god,
thing
Sam,
where
it's my
this thing.
calculator.
It's this thing.
Second.
Power.
E.
It's a very useful button.
It's E to the x. You're looking for E to the x, which is second natural log, second ln,
And then times 5.
times 5. I'm going to close parentheses.
Yeah.
Parentheses here were optional because I'm in the exponent. If your calculator does not let you write in the exponent area,
Okay.
That's like Desmos.
Dollar sign
Desmos does that.
13,942. Or 13,942.
continue. You're not done.
0.01091.
That's not correct.
Why? 0.01.
Yeah, so I would write as my answer, I would write $ 13, optional comma, 942.01, checking the third digit for rounding. I don't need to round, so I'm done with 2 decimals of precision. That's how to do it.
Awesome.
Super awesome.
Well, I couldn't figure out how to do it because I tried doing multiplying the exponent and then doing 12,000 to the number I got, and that didn't really work.
Okay. Somebody remind me what the answer was.
Could you scroll up a little bit?
13,942.
That's wrong.
Dollars.
$,
Dollars.
13,000,
192.
492,
942.
942.01. What do you notice about these 3 answers?
They're similar. Very, very close.
So here was my answer for A. Oops, it's not my
Why
highlighter.
is there a 2 on the end of the thing of all right?
Here's my answer for B. Where was my answer for B? It's here. And here's my answer for C. Why is there a what, Sam?
Never mind. Well, I was just wondering where the 2 was coming from, like what the 2 is on part A, like right above the answer. It's
Those
a-
just.
This. I was checking the. So whenever I want to report 2 decimal places, I have to go to the 3rd decimal place and see if there's any rounding that needs to happen. So I was doing that as sort of an intermediate step to double check if this should have been 0.22 because of a digit of 5 or greater over here. What do we notice about our 3 answers?
They're like within 5, well, almost. Within 10 of each other.
How many times did I compound interest for quarterly?
4,
How many times did I compound interest for
12,
monthly?
12.
How many times did I compound interest for continuously?
You didn't.
You could say infinite. So what's the trend here comparing these numbers?
It gets bigger.
It does get bigger. Only compounding interest 4 times a year. I get a little bit more if I compound interest monthly. If I compounded interest daily, would it be less than this, between these two, or more than this?
Between monthly and infinitely.
Right, because daily would be 365 times, and so it would be here between the purple and the orange.
Wait, Mr. Shadle, for number 2, what would your T be?
5 still.
Yeah, for every one of them, it's t has been 5.
Awesome.
So what's changing from A to B to C?
Just the amount that you're not amount of time. but
So
like
n changes from A to B. What changes from B to C?
There is no n.
So what changes?
The formula?
The formula itself changes. Yeah.
Oh, why'd you bring me this watch? I don't really remember now. You're fine. Yeah, 5 times 12 is 16. That's cool.
I'm going to try to put all this stuff in here without actually having to type it. So let's see how it happens. Let's see how well this works. In 1986, a nuclear reactor accident occurred in Chernobyl in what was then the Soviet Union period. The explosion spread highly toxic radioactive chemicals, such as plutonium, open parentheses, 239 Pu, close parentheses, over hundreds of square miles, and the government evacuated the city and the surrounding area, period. To see why the city is now uninhabited, consider the model.
Wait, I don't know if this was the question, but there was a question about plutonium on the homework.
Oh, this is going to be radioactive decay.
Better than stoichiometry. Charlotte rules. I hate stoichiometry.
Stoichiometry is awesome. It's math for chemistry.
Stoichiometry's not that bad.
It's like fine when you get it, but when you don't, I just want to die.
Where's the backspace button?
So, so to investigate why the city of Chernobyl is still uninhabited,
Wait.
we're going to look at the model P equals 10 times 1/2 raised to the R over 24,100.
Mr. Shadle.
Hey.
You should give us time to write that down.
So, so you should write down radioactive decay. You should write down 239 Pu. That's this should be 239 Pu, plutonium. So plutonium as a radioactive element.
Word up parentheses.
And a government evacuated the city and the surrounding area, period. To see what is now inhabited, consider the model, period.
Wait, where'd you get 1/2?
That's that is the formula for radioactive decay. And it's different for each element. Each radioactive element has a different formula.
Memorize those. Like for
You will not have to memorize this, but if you're given this on a problem, you should be able to use it.
Okay.
initial.
Initial? Is that an M?
Without an N.
Oh, I said, there is
So
no
this
M.
this is the half-life formula. This represents the amount of plutonium that remains from an initial amount of 10 pounds after T years. Oh, that's an R. That's a T. That's a T.
Oh, and what's the, is it 24,100?
Yes,
Okay.
right. Yeah, that comma might have messed you up. It's 24,100. Looking at the looking at the formula, where do we think, Eric? Where do we think this 10 comes from?
10.
I know where.
I'm writing the question. Is this right there?
Tell me.
Initial amount of 10.
Yes, it says initial amount of 10 pounds. So similar to the way we were compounding interest, at year 0, we had how much plutonium?
Oh, wow.
At year 0, at the time of the incident,
10 pounds.
we had 10 pounds.
So evil. And she clocked me.
Sydney, how much plutonium do we have
I
at
just
the
answered
end
the other one.
of? I know, but you're talking to, so I want you to get back to class. What happens at the end of the first year?
It would half that, half the initial, so let me type it into my calculator just for you.
Actually, what happens is,
Or would it just be 5?
let me just tell you. I'll just tell you.
Okay.
So I'm going to do 10 times 1/2
Is that 24,100?
of 1 over 24,100. At the end of 2 years, I have 10 times 1/2 times, this is kind of an unsimplified fraction, but I'm doing it for a reason. After the end of 3 years, I'm going to have 1/2 times 3, or to the 3 over 24,100. And then after, Eric, after 24,100 years, how much plutonium is left?
5.
What do you mean? What is
So after 1 year, I have 10 times 1/2 raised to the 1 over 24,100. After 2 years,
after this year,
after 24,100 years, what do I have?
so you have 10 multiple 1 over 226. 5
What's my exponent?
is 1.
It's 1. So here I'm continuing the same pattern. I have 24,100 over 24,100. That's the same as 10 times 1/2 raised to the 1 power. That's 5 pounds. 5 pounds. So this is why this formula is called the half-life, because after 24,100 years, that is the half-life of plutonium is 24.
In chemistry.
The half-life of plutonium is 24,100 years. That's how much it remains. Half remains after 100 years. So how much is left after 48,200 years?
25? No, wait.
What?
Am I crazy? Would it be 20? There's no way it went up.
Doesn't go up. It goes down.
Oh, 2.5.
Yeah, it's 2.5. What is it after 96,400 years?
1.75.
Yeah, it keeps halving every 24,100 years. That's why it's called the half-life. So if I say how much is left after 10,000 years, how much plutonium is left after 10,000 years? Carlo.
That would be 10,000 years.
10,000.
Okay.
Tell me how to write it. Don't go to your calculator yet.
Oh. It's the formula,
What is it?
and just 10,000 over 24,100. 10 parentheses 1/2 to the power of 10,000 over 24100.
Right. And that's what?
That's 7.5.
7.5 pounds. Does that make sense? It's less than 10. It's more than 5. This is between year 0 and year 24,100. Does that make sense? Kira?
Would it be 96,300 because it's only 100? Because you go from 40.
Oh, did I? I think I doubled it. I doubled it. So what should it be?
69,300.
No. I doubled the half-life. So what should the answer be?
Oh, double the half-life. No, half the half-life.
Half the half-life.
Which is 1.75.
No, it should be. So I didn't add an additional 24,100, which I perhaps should have done.
Oh, it's a quarter.
It's a quarter of it. So what's a
Okay.
quarter of 2.5?
I don't know.
6.3.
It's not going to be 6. It's not going to go up.
Oh.
0.625.
0.625. So that's 2.5 divided by 4. So Amelia, help me figure out how much plutonium is left after 100,000 years.
Okay, after 100,000 years, there is. Wait, did
I'm gonna rewrite my formula at this point.
you already wrote it down? Oh, sorry, I think you said 10,000 years. Sorry. Okay, so 10, 1,
That's supposed to be 1 over 2,
and then
and then it's t over 24,100.
yeah.
So what is p?
What is P?
How do I write it now for 100,000?
100,000.
Yeah, t is 100,000. Well, how do I figure out what the amount is?
You do P equals 10,
Mm-hmm.
and 1/2, and then 100,000 over
10 times 1/2
and then
to the
to the 100,000 over 24,100.
Can you put that in your calculator and give me an answer?
Yeah. Uh, 4.15 pounds.
So
That's not what I got.
so 4 pounds is not a reasonable answer
Wait, sorry. So
because at 96,400 we had 0.625.
Alright, good.
These, what do you want us to rounding to? Just 3, if it doesn't specify?
If I don't specify, let's always assume that it's 3. But if I specify, then make sure that you do it to those digits because otherwise I'm gonna take off half credit.
Got it.
Half?
Point.
Yes, half. If you don't put units or round properly, your answer is not accurate.
Okay.
And I'm being generous by not taking off all credit.
0.5635 pounds.
Just 4. Just round.
0 point. So we always write the 0 point, even if we say 0.56, we write 0.5.
5, 6, 3, 5.
Okay, and Kira said, what's the default number of digits? And I think the answer, if it's not specified, 3 digits of precision is probably good. So let's rewrite our answer.
0.564.
564. We're not done.
Pounds.
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 Right. You see how I'm writing approximately equal? Squiggly, squiggly. That's approximately equal because we are rounding. So it's about a half a pound after 100,000 years.
So anytime we round ever, we squiggle it?
That's a good idea. Right. I didn't do it on the bank account.
What is this?
I didn't do it on the bank account because it's not approximately $13,942.01. That's it. They will truncate it at the bank, and that is your bank account. That's your account balance. So I feel very comfortable stopping at 2 digits because that's how we do cents, and calling it equals because that's your account balance. For something like this where you're taking an exact value,
It's just an approximate equal sign.
this is an exact value, this is an approximate value, so I think it's appropriate to use the approximately equals sign. And the book does that as well. We finished 5.1.
That's it?
Woo!
That was not really.
Yeah.
Finished 5.1. Okay, just to torture you,
Quiz. I want to do a quiz.
Whoa,
Oh, hey, you're
Lester.
funny. Yeah. Boring.
just to enrich your life, I'm going to show you how we get from the discrete compoundings formula.
Just a tad.
Scroll down. To the, what's the other one called?
Continue.
Continuous compounding. Did we do the limit choo-choo train?
No.
Oh, yes, we did.
Did we do this?
Yes, he did,
yes, he
did.
So if I have 1 compounding per year, 2 compoundings per year, 3 compoundings per year, 30 compoundings per year, 100 compoundings per year, 324 compoundings per year, what limit is my function approaching?
0.
It's not 0.
Oh, it's 2.
It's not 2.
0.7.
What symbol do we give for this number?
E.
It is approaching E. Right. So just kind of off to the side, we're going to take note of that. We're going to say the limit as x approaches infinity of that formula. What was that formula, Warren? What formula approaches E?
I wasn't looking. Can you go back? Okay, fx equals to 1 plus 1 over x.
Mm-hmm.
The power of x.
Yeah. fx
So what was it?
equals to
1 plus
1 over x parentheses to the power of x.
to the x, and as x approaches infinity, this function approaches E. So it equals E as x grows unbounded, it equals E. So remind me how we figured out our discrete compoundings formula. So if you have a bank that compounds interest every year, what is your balance when you first open the account?
0.
Your balance.
P.
P, yeah. So P. And then what happens at the end of the first year?
Oh, it becomes like P plus 1.
It's not P plus 1. They don't add $1.
Oh, it's
P times
P1.
P times 0.03.
It's your principal times your rate, right? So if we have $925 and we have a 4.5% interest rate, then you open your account with $925,
That's a weird.
and then what happens at the end of year 1?
You get 925.
925
925 times
plus your original balance times your interest rate. 0.045. And then you can figure out what that equals.
You need to
What-
see a dollar sign.
Right, for my final answer, I'm going to supply a dollar sign and use 2 digits of precision.
Didn't we do this?
Yes.
Oh, okay.
What's the formula? So I'll call this P1. This was just P. What's P2?
P parentheses, or yeah, P one parentheses. No, parentheses. 1 plus R squared.
Right. It's actually my original balance. It's P.
Yeah.
And what happened at year T?
It
What is
to the
Sam? What's P sub T?
Piece of T would be 9 point.
What's the formula? We can once we figure out the formula, we can put in the P and the R.
Is P equals 10 and a half. 10 parentheses 1 half.
No, that's decay. We're not on that anymore. So what we're sort of probably covered last time and are not really doing as explicitly this time is how can I rewrite this more simply? What can I factor out of this, Carlo?
Out of
P plus PR.
P,
Factor out P, and that leaves me with what?
R. Or
No.
P plus
P? It's not a P squared, so I don't have P left over. If I factor out P from this, what's left?
You did not finish that one question.
no, the R is left.
R? So if I multiply this out, do I get P plus PR?
No.
No.
P plus R.
P
No.
plus R?
No,
No.
that's not right.
No.
1.
Yeah.
What?
1
1
plus R.
plus R. So if I multiply this out, what do I get?
You get P plus PR.
Right, that's what I wanted. So that's the right way to factor that out. And then at the end of year 2, then I start with my original amount, and I do another 1 plus R. So I can rewrite that as what? Warren, how can I write this in a more compact way?
E parentheses 1 plus R squared.
Squared. Right. And then in year 3, I'm starting with this. Starting with my previous amount. And I do it again. And how do I write that more compact in a more compact way, Sam?
I don't know.
Yes, you do.
Yeah, you do. You got
How do I rewrite this?
P parentheses 1 plus R parentheses 3.
Right. And so we see the pattern all the way down. So what's P sub T?
It would be P parentheses 1 plus R parentheses T.
To the T. Right. Right. So if for yearly compounding, like once per year, that's actually my formula. So, Kira, remind me my discrete compounding's formula.
P parentheses 1 plus R over N parentheses N to the T or N to the NT.
To the NT. So this is the same formula.
You just added an N.
This is the same formula when n equals what?
1.
1. Do you see that? R over 1, T over 1. I said 1 times T. That's the same formula, right? Amelia, are you convinced of that?
Yeah,
Or are you messing with your hair?
it's not the same formula.
It's not? If I say n equals 1, what is this formula?
Well, then it is the same.
Yeah, for n equals 1, it's the same formula. So number of compoundings per year, this is the formula if you just compound once per year. Okay, and then let me see, did I write that off to the side? A long time ago. So I'm gonna bring this down because I want to use this again. I would like to find out what this should be. So like if I say 365 compoundings per year, then I just put in 365 for my n. But what happens if I want to compound once per second or twice per second or 100 times per second?
That would be really hard.
So I really don't want to have a huge number here, and I really don't want to have a huge number here. I would like to use the fact that this formula in the limit as x grows unbounded turns into e. So I'm gonna do a little bit of substitution here. I'm gonna introduce a variable. I'm gonna say let m equals n over r. And then how do I rewrite this formula substituting in m? P's not changed. 1's not changed. Sydney, what do I do next?
You would plug in the R over the T. So, well, where's the formula?
Here's the formula.
No, like where are the numbers?
No, I don't want specific numbers. I just want to say in general.
Then R over, right? R over N.
If it's
To make it easier, I'm gonna say what n should be. So let me substitute in for n. What is n?
365.
No,
1.
no. I'm introducing a variable to help me rearrange my formula. If m equals n over r, what's n?
RM.
Right. Mm-hmm. So what's this term now, Sydney?
So then it would be MR plus MR. Or no, sorry, R over MR.
R over mr, which is gonna simplify, and then what's my exponent now?
It would be 365 T.
No, forget about 365. That was just an example.
T.
I'm rewriting this formula. It's not t.
Okay, then I don't know. Oh, N equals 1?
It used to be nt,
Okay.
but I'm substituting that out. Warren,
Oh, MRT.
Warren, what's my exponent now?
It's gonna be MRT.
Right. I'm substituting in for n. N is mr, so that my exponent now is mrt. I'm going step by step to try to get this something in this form. Okay. Eric, can I simplify my fraction?
You can write. Simplify A equal to.
No, I want to simplify my fraction.
I just add 1 over n.
1 over m. Why is that? Why is that, Amelia?
Why is m over n?
How do I simplify this fraction?
You like multiply m and r. Yeah, I'm confused.
1 over.
How do I simplify? What's What's 3 times 2 over 2?
3 over 1, which is 3.
Yeah, it's 3y.
Because it is.
No, that's not because it is not an answer.
I don't know how to explain it.
What did you do to get there?
Because, okay, well, 3 times 2 is 6, and then 6 over 2 is 3 over 1, which is the same thing as 3.
Okay, that's true. What if I had a times b over b? What's that?
I don't know how to, I don't know to simplify it.
What is a times b over b?
I don't know. I don't know how to simplify it when it's just letters.
You don't?
No.
What is t squared over 3t? What does that simplify to?
T over 3.
Yeah, it is t over 3. Why? How did you get there?
Because you cancel out the t.
Cancel out a t here, cancel out one of the t's here. What about a b over b?
It's just a.
It's just a. Why?
Because the b's cancel.
B's cancel. What about the 3 times 2 over 2?
Because the t's cancel.
Okay, what about r over mr?
It's just m.
It's just m?
Well, it's actually, I think it's just 0. 'Cause
It's 0?
Well, nothing is on the top.
It's not nothing that's on the top.
No, because r cancels out, so there is nothing on top.
It's not nothing, it's not 0. What is a over ab? Or 2 over 2 times 3. What is 2 over 2 times 3?
1 over 3.
Yeah, it's 1 over 3. Because what?
Because it cancels out.
The 2's cancel out, leaving a 1 in the numerator.
Yeah.
So can we apply that to this simplification?
Yeah. So it's 1 over m.
Good job. And we're left with MRT up here. And I'm getting that much closer to what I'm trying to do. I'm trying to get it in this part in this form. So I'm going to put in another couple of parentheses. I'm going to put this in as a big old square bracket. It just means the same thing as a parentheses. And what do I prefer to have as my exponent here? I'd like to have an m. So I'm gonna make the RT wait outside. So what is this formula now as m approaches infinity? So in the limit as m grows without bounds of this 1 plus 1 over m to the m to the RT, what happens to this as m grows without bound? Warren,
Yeah.
what happens to this as m grows without bound?
It approaches e.
Yeah. So the limit of this formula now is p times e. What's left? What's left over?
RT.
RT. There's my continuous compounding formula.
Whoa.
That's how we get PERT from our original.
Interesting.
Pretty long process.
Pretty long process. You don't have to know the process. It's just to show you how we got here from there.